Welcome to Demystifying Math. In this lesson, we're going to be using Cramer's rule to solve systems of equations that can be represented by 3x3 matrices. Before we begin, let's recall the formula for the determinant of a 3x3 matrix. If you eliminate the first row in the first column, your intersection will be A, and the remaining 2x2 matrix is EFHI. So we're going to take A and multiply it by the determinant of the 2x2 matrix that's remaining. Next, we're going to eliminate the second column in the first row, and our intersection is B. With the second column in first row, you're going to multiply the intersection by -1. So we're going to subtract B times the remaining matrix, the determinant of the remaining matrix, which is DFGI. Next, what we're going to do is eliminate the first row and third column, and our intersection is C, and the remaining 2x2 matrix is DEGH. This is your formula to find the determinant of a 3x3 matrix. So let's do an example. Using this matrix and eliminating our first row and first column, we have an intersection at -2. and a remaining 2x2 matrix of 4, 1, -5, 2. Next, we're going to eliminate the first row and second column. Our intersection is 3, and we're going to subtract that and multiply it by the remaining 2x2 matrix, which is -3, 1, 1, 2. Next, we're eliminating the first row and third column. Our intersection is 2, and that's going to be multiplied by the -3, 4, 1, -5 matrix, or the determinant of that matrix. Now we have to find the determinant of the 2x2 matrices. So remember that when you're doing that, you're going to multiply across. So the determinant of 4, 1, -5, 2 is 4 times 2 minus 1 times -5. Then that's going to be multiplied by -2. And we did the same thing for the other two determinants. And we ended up with a determinant of 17. Well, what we wanted to do in this lesson was to use Cramer's rule to solve a system of equations. And Cramer's rule allows us to use determinants of 3x3 matrices to solve systems of equations. What Cramer said is that x is equal to two determinants that are divided. The denominator one is simply the coefficients of x, y, and z. In the numerator, we replaced the coefficients of x with the constants j, k, and l, and everything else is the same. We do something similar for the y variable. We replace the y coefficients with the constants, and that goes in the numerator. So our second column is JKL. The denominator is exactly the same. It's just the coefficients of x, y, and z. Now for z, we're going to replace the coefficients of z, or the third column, with JKL. And our denominator again is the same. So this will be a formula to find x, y, and z using Cramer's rule. So let's do an example. For our x variable, the denominator is simply the coefficients of x, y, and z. To get the numerator, we're going to replace the first row with the constants, -7, 15, -24. And then we're going to evaluate the 3x3 matrices, the determinant of those 3x3 matrices. So if we eliminate the first row in the first column, our intersection is at -7, and the remaining matrix is 1, -2, -5, 1. Then we're going to subtract the intersection of the first row and second column, which is -2, and multiply that by the remaining matrix, which is 15, -2, -24, 1. The intersection of the first row and third column is 3, and the remaining matrix is 15, 1, -24, -5. And we did the same thing in the denominator. Then evaluating those determinants and multiplying by the coefficients, we ended up with negative 156 over -78, which is 2. Now keep in mind that the y variable can be found by using the same determinant in the denominator. So we're going to just replace the denominator with negative 78 to evaluate the y. In our numerator, we're replacing the second column with the constants. And then we're going to evaluate the determinants. So we ended up with 5 for y. Now once you've solved for x and y, you can easily go back and plug in to find z. But in this case, we're doing an example using Cramer's rule, so we're going to go ahead and find z in the same way we found x and y. So for z, you're going to replace the third column with the constants and keep the x coefficients and the y coefficients. And then evaluate your determinant, and we ended up with negative 1. Now you don't want to go ahead further with this until you've checked your work. So we're going to plug it back in to all three equations and make sure that we got the right answers. So we did get negative 715 and negative 24, so it works out. All right, thank you for watching Demystifying Math.